So, welcome. The next hour, hour and a half, I'm going to be talking about logging, monitoring, instrumentation, alerts, and I'm going to target developers. So not really operators, but developers. But before that, you're all dying to know who am I. My name is Henry Been. I like to make funky sounds. And I'm also a independent developer and architect, and my focus is on Azure and DevOps. What I really enjoy is delivering value to my customers quickly, fast, and often. And one of the things we need for that is instrumentation, logging, dashboards, and all that stuff. So that's what we're really going to be talking about tonight. So I have been giving great thought to how to structure this talk. And especially being inspired by Pat, I don't know if he's still here, who challenged me on Twitter to do not give a boring talk. I came up with this. The three things I'm going to do. I'm going to start off with a pretty boring part, then a less boring part, and then a part that I hope is not too boring. So I talked to my wife about this, and she said, "You're always so negative." So I took her view on it. Well, that didn't really help either. So to get to the point, this is what we're going to do. We're going to talk about a bit of theory behind monitoring. Then we're going to talk about what to monitor, and much more fun about what not to monitor. Like Patrick showed you earlier, it's always much more fun to look at what not to do, the stupid things. And I'm going to try and finish by giving you a number of demos on how you can do this on Microsoft Azure, my cloud of choice, because apparently there are more. So monitoring, this is the boring part. So don't worry, it will get better, I hope. So for me, monitoring is about knowing what is happening in your production environment. It's not about a graph of CPU usage, which for some people it might be. For me, it's about knowing what is happening in production. And not really about my servers, or maybe not even my applications, because screw those. What I'm interested about are my users. Are my users having a good time? Because if they are giving me money. And money gives me bread and beer. So, monitoring. What are we really talking about in concrete? Three things. First of all, instrumentation. And I think of the three parts we're going to talk about, this is the one that is most often forgotten. Instrumentation is the art of measuring all kinds of things about your application and the environment or the stack it runs on. Things like CPU usage or the temperature. Those are metrics that I can gather. Things with a specific value at a specific point in time. Now, there are a number of things about metrics that make them interesting. For example, next to plain metrics, we also have events. Things that don't really have a value at a specific time, but happen at a specific time. We can just model those as metrics with a value of 1, so we can count them. Another thing that's interesting about metrics is that they can have dimensions. That does not only sound cool, but it also helps us reason about them. So if we take the temperature, for example, let's take the temperature in this room, we can call that a metric. And we can call the temperature in the hall also a metric, so we have two metrics. But what is much more useful is having one metric temperature with a dimension location, which means that I can record the temperature for each location, but also really easily average the temperature over both locations, for example. And of course, metrics are like a series of values over time, which mean that I can put them in a graph. Multiple graphs make up a dashboard. And an alert is when a certain graph goes below or above a certain point. So that's how they relate to the other topics. Another thing you should know about metrics is that if you start recording them, for example your CPU usage, is that you will get a lot of data. If you measure your CPU usage in a percentage every, I don't know, 10 milliseconds or 100 milliseconds, that will generate a lot of data. And the data is really valuable if it's really recent, because it gives you insight in what's happening on your server. However, it's not really interesting anymore in a couple of weeks. So what you can do, I'm put with my back against the wall here. So what you can do over time is like average them out, for example, over a second or over a minute. That way the amount of information that you have to store decreases, but the value that you can get of the data doesn't really decrease because it's longer in the past. You can still see trends over time. You're not really interested anymore in the sub-second changes. So that's instrumentation. Another thing that we have to think about is tracing. And it is probably what we developers call logging. This is just, I'm going to have my application at a lot of points in time emit details about what it is doing. Entering method, leaving method, entering the for loop, doing another loop, that kind of things. That's tracing. And it's really concerned with what my system is doing. A certain place in my code is being hit at a certain point in time, and it's maybe taking a certain decision. So this is really system oriented. It also generates a lot of data. A lot of matrix. So you're probably going to retain it for a limited amount of time. I don't know, a week, 2 weeks. And that's probably enough for the reason you are collecting it to troubleshoot issues of your users, or I don't know, find performance issues. And finally, we get a thing which is in theory called logging, but we developers probably call auditing, which is concerned with recording all the system changes that occur over time. So basically noting down all the business decisions that the system takes. And this is not really interested in looking at the system anymore. This is looking at the business and the users. And this is where you go if you want to find out why you delivered 452 pizzas to your grandma. Or this is where you go if you want to find out what a hacker did the last couple of months after you found him out. And this is just also information that you store for a much longer period of time. And if you're smart, you're going to store it for forever. Now these two, tracing and logging, you're probably going to record them definitely in your application using the same means, the technical means. It's just you have to be aware of the difference between the two so you can cope with them, especially when it comes to retaining them differently. Now, that's all nice and well, maybe a bit boring, but still nice and well. But you might be wondering, what would an architecture look like to record all this stuff about my application? So what you would normally do is have an application instance. This is where your code, that's your code, which is running on something. It can be serverless, but then it's probably still running on an Azure Function app, for example, which is an application container, or a virtual machine, or an IaaS instance, which we also call an app service. It can be a VM, or it can be a container. Don't really care, just don't use containers. Another thing you're going to do is in your application, you're going to install an SDK. This is the thing that you're going to use to emit logs and events from your own application, things your application code generates. And on your application platform, you're probably going to install an agent, which is going to collect things about the platform that your application runs on. Now these two start generating information, has to go somewhere, so why not push it to an HTTPS point? That's what we do with everything in 2019, so we do it with metrics and logs as well. And from there, we're going to do two things with it. First of all, we're going to store it in a database. For example, application insights might even be a regular database if your application is small enough. Wouldn't recommend it, but it's possible. And of course, once it is in a database, all these log entries, we can query them kind of like you would do with a SQL database. For the metrics, however, we're going to use a specific type of database, which is called a time series database. These are databases that are optimized for storing these values with a timestamp that, give graphs over time. They have embedded things like minimum, maximum, average, over time, rolling up, all these kind of things that specifically go for metrics. Now, you can run queries directly against it, but then you get a table. The tables are boring, so you're probably going to have a visualization engine running against the data store, and on top of that you're going to write your queries, which are not going to emit tables, but graphs. Those graphs combined are going to be your dashboards. Now this is all concerned with storing it and querying it later. And we don't want to do this because we do not want to query every morning if there was an outage last night. So we want to also create what is called a hot path. And it's a term that I'm borrowing from the data platform, where the cold path is about storing data for usage later, and a hot path is concerned with streaming data engines. Here we are not going to store the data, here we're just going to guide all the data through the query engine, which already holds the queries. And all the queries are just lining up there, watching all the data go by, and just picking out records they find interesting. And with those records they find interesting, they're going to answer the query that they're responsible for. And the data that's not going to be stored, it's going to be dropped on the floor afterwards. And whenever a query returns a 1 instead of a 0, it's probably going to fire an alert. So this is a different architecture than storing all the data and querying it later. Now we can do that for metrics, but nowadays we can also do that for logs. So this is kind of a logging and metrics architecture for you. The slides will be available later, so no need to take pictures, but feel free. Now at this point you might be thinking this talk was for developers, but this is the domain of operators and not for me as a developer. Why would I care? As always, I like turning questions around. But let's start. Why would you not be why would you be interested, but for the wrong reasons? DevOps power. DevOps is cool, which means that as a developer I need to do everything that an operator does as well, which is a possible interpretation of DevOps. You can call it no-ops then. And it might even fly for you if you're doing really modern cloud development and you can abstract almost all of the responsibility of operators away. However, I think a better reason is that DevOps, they're really important, focuses on collaboration between developers and operators. And cooperation comes from understanding. And for that reason, I believe that developers should know about what operators do, at least to some level, to talk to them and to work together. Also, when it comes to instrumentation, an operator can set up all the platforms he wants, but if you do not emit metrics from your code, there's nothing to graph and nothing to alert upon. So that's why I believe that you should care. And now you care, I hope. So, yes you do? Do you care? Yes, awesome. Whew. No, otherwise we wouldn't be getting a beer right now. Okay, but so you care. Like I said, it's fun to turn questions around, so let's think about what not to monitor. And I find it interesting because what I see a lot of the time at a company when they say, oh, we've got this new application, it runs on these VMs, we have to put it in the monitoring, somebody runs by, measures CPU, measures memory, page I/O size, and yay, we're done. It's in the monitoring. And what does that really tell you about how happy your users are using that application? Nothing really. So one thing not to do, in my opinion, is overly focus on your systems. Your users do not care about your page file size, or your disk I/O, your CPU usage, or whatever. Or it doesn't really relate to, for example, business outcomes like conversion. Another thing not to do, is also fun, is not focus on averages. When we get into like the standard put it in the monitoring solution, we get people generating like 4 graphs of the average CPU usage. And it's always 70. Because we have 6 machines. And there is 1 at 0 and there are 5 at 98%. I'm just making up the numbers, so I don't know if they add up. But averages are lying, cheating bastards. So I would not really rely on them too much. Use maximums, or even better, percentiles when you can. Now, to add some nuance, which the people who know me is what I really excel at, system metrics are of course handy to troubleshoot issues, and they give you some insight, and it might be leading indicators, but just do not focus too much on them, in my opinion. And the same goes for averages. So let's have some fun. This is a graph that I made up to serve a purpose of the average system response time of an API. No, I'm lying. This is a graph of the average usage of a database. This is an Azure SQL DB, and the database usage is measured in the percentage of data transfer units, which is like the Athlon XP. It has a number, but nobody really knows what it means. And this number, in this instance, was always like 10%, 15%. Users were happy, and then all of a sudden it bumped up to close to 100. stayed there for a while, and then dropped down again. Was the user of the application that was using this database happy? Who thinks he was? Okay, he was a hacker. Okay, who thinks the user was not happy? Okay, so more like most of the people. I know the user was happy. So the operator came running to me and he said, well, we have to increase the amount of performance that you allocate to this database because the user is not happy. Something is wrong. And I looked at the graph and I said, nothing is wrong. We're actually using what we're paying for. So that's a good thing. Well, they disagreed. They proposed, first of all, fail forward, put an alert on the database usage. And secondly, to scale it up whenever that alert was hit. So I didn't want to go that far. I said, let's call the customer and ask what was happening there, because this was a new pattern. So we called the customer, and what was happening, it was one of the largest customers of that application, and he started running a really heavy report whenever he felt like coffee. So that user of that application was really happy because he had a reason to get his coffee. If we gave him more performance in the database, that user would be really dissatisfied because he wouldn't get coffee and the price of the product would go up. So don't look at graphs only. That's the point I'm trying to make here. And especially do not look at graphs of your systems only. Another thing, this is the graph that I promised earlier of the average response time of an API. These are made up numbers, but they're based on a real world scenario. Around 100 milliseconds. Is my user happy? Who says yes? Okay, who says no? Well, I don't have a clue. But what I did is I was adding, this is the maximum response time in the same intervals. Like I said, they're figured numbers. But as you can see, it's probably most of the users are happy, but some of the users are not happy. This is what you can get from maximums. What I can also do is take the same graph and not split it by the average and the maximum, but split it by operation. In this case, I'm using dimensions. So what we're seeing here, there is an operation, view item in my web shop, which is really responsive. Users are happy, they want to buy it. Takes too long, they go away, I don't sell nothing. So this is another scenario where averages are liars. So the point I want to try to make is, well, I'm not going to do that, but percentiles really fits with rhythm. But consider using percentiles. And also measure things the user cares about. And think that through, because that's not as easy as you might think. So let's look at a demo. So this is an awesome dashboard that I created in Azure. And we will look at how to create those for your own applications later on. But I want to draw your attention to the top right, where I am graphing the average delay for processing a queue message. And the operation that is behind it is a user is adding a URL indirection to a URL shortener. It takes about 1.5 seconds on average. Is my user happy? Well, probably not, because when he refreshes his list, it's not there yet, and he's going to try re-adding the same thing probably. But the issue is much, much worse than you think. Because this is the maximum queue delay. So for some users it's working kind of okay, but for some of them it's not working at all. I know the reason. I added an exponential delay. So that's the reason we get these peaks. But what I'm measuring here is really interesting. I am measuring the end-to-end delay between queuing a message and actually handling the message. Well, the native thing to do for some people might be to measure this. The average number of messages waiting on the queue to be handled. And this is a system that goes through thousands of messages per minute. And if you just look at the average number of messages waiting, you might be thinking everything is in order. The point I'm trying to make is really think about, are you measuring the user experience or just some random number that comes from your systems? Now, these insights about monitoring the user experience instead of your systems is something that I came to realize over the last couple of years. So that was my fault, because somebody wrote a really good book about precisely the same thing years before I started thinking about these things. So the book is called Practical Monitoring. It's written by Mike Julian. It's a really good book. Would highly recommend it. For those who do really fancy reading, it's also quite thin, really helps. So highly recommend it. So this was the middle part, the part that I hope that you found a little bit less boring, thinking about what to monitor and what not to monitor. And the last thing that I want to talk to you about, or a few of you in the next 15 minutes or so, is how to do all these things in Azure, how to implement instrumentation and monitoring in your own applications. So, demo time. I'm going to talk about a to-do application, and I've been lying because it's almost demo time, because I think it's good that you know about the architecture of this tremendous, amazing application that I've written. It's an Azure Functions app. And what it does, it has one HTTPS function called URL shortener, which you can call with a URL and an alias. Then it's added to the database. And you can just call it with an alias, then it gives you a redirect to the URL of that alias. Kind of what you would expect. Adding an alias is done through a queue. I'm not really good at graphics, so this is my queue sign. And of course I have a SQL database below that to make it all working. Now hopefully through the rest of the 15 minutes remaining, you're going to recognize the architecture that I draw with you together in the rest of the demo, because the rest is going to be demo. So let's explore how you would do this in Azure. And like I said at the start, there are like two levels of monitoring and logging to think about. The stack below your code and from your code itself. So let's start with the easy thing, and that's the stack below my application. And for that, in Azure, we're going to use a thing called Azure Monitor. And the Azure Monitor is built into every service, for example, SQL databases. So let's go there and open up this example that I prepared. Whenever you open up a resource in Azure, you're probably going to get a graph. These are metrics emitted by Azure automatically to the monitor service automatically. All the servers in Azure are now connected to the Azure Monitor. They spend a lot of time over the last couple of months, I think the last couple of years maybe even, to centralize the monitoring experience through the whole of Azure. And it all works like this. So let's click on a graph. What I can do is I get a pane where I can start graphing whatever I want, and I can add lines. And every line is recognized by 4 parts. The service that the metric is coming from, the namespace that the metric is coming from. There's just a one-to-one mapping here for all the Azure generated metrics, and the metric that I want to graph, and the way I want to graph it, which is min, max, average, no percentiles, but still more than just averages. So let's, for example, say I want to just draw this graph of CPU percentage, and I do the minimum. If I'm happy about this, why not just add the maximum as well, so I can see what happens within each interval. This is how we can build graphs from metrics in Azure, as easy as that. Now I said dashboards are just a collection of graphs. So what I can do here on the top right is click on Pin to Dashboard. So let's do that. And I can add it to the dashboard that I currently have open, or select one of the dashboards that I already have. And one of the things I can select is create a new one. That is how I built this dashboard as well. It took me, I think, a couple of minutes. So that is how easy it is to get dashboards in Azure. This is all built-in functionality. And the thing burning in your mind now is, what does it cost? Right? It's all included with the resources you're already paying for. So if you're not using it, there's no extra charge, and you can start generating these graphs and these dashboards automatically. You can do things like full screen this, put it on a wall mount, put in a transparent screensaver on top with a password. Do not leave them just like this, and you have dashboards up in your company. Another thing you can do is share these dashboards with your fellow colleagues. But this one is already shared, so here's an unshare option. And what happens when you share a dashboard, it will be wrapped up and made available as a resource in a resource group, just like any other resource in Azure. Well, and that's something to keep in mind. We will get back to that, but let me spill the beans a little bit. Every resource in Azure is, for example, governed by the Azure Resource Manager, which means that you have role-based access control available, so you can manage authorizations on dashboards, like any other resource. Now, watching graphs all day is like watching fire, fascinating, but it gets boring in the end. So one of the things you might want to do is like get notified whenever a graph gets below or above a certain value. So I just open up a graph, click on the button New Alert Rule, and I get this immensely confusing interface, which is not that hard to work with, but it takes some time getting used to. When I want to build up an alert, I have to select a resource first, which I have already done since I'm coming from an existing graph. Then I can specify a condition under which I want to get alerted, which is a combination of a metric and a threshold and an operation. To make that less fake, let's say the threshold value is 90%, and I want to get notified when the average is greater than 90%. Then I can specify how often Azure should evaluate this rule and the window of time it should look over. That is all I have to define to specify an alert. Now, an alert in itself is not really useful if it doesn't trigger anything. So what an alert triggers is called an action group. An action group is nothing than a label and a series of actions. And an action is like email Henry, text the CEO, can be fun. But can also be called as webhook, which might, I don't know, do an automatic scale up or text the CEO. Now, these action groups are reusable, so I can define them once and then use them for multiple alert rules, which is really handy because you're probably going to have multiple alert rules and not want to repeat all these email addresses and phone numbers. And also, if they change, you want to change them in one place. So that's how you define alerts. Now, I have defined all these things of the resources that I was working at. You might also be wondering, what if I want to start from nothing? In that case, you can go to the monitor in the menu on the left, which is just an Azure resource provider like any else, where I can, for example, go to metrics. I get a graph pane again, and now I have to start with selecting a resource, which is quite cumbersome, so I'd recommend to go the other way around. And I can go to alerts as well. Now here I will get a list of all the alerts that have fired under the conditions that I'm selecting at the top. There's a really annoying bug here, that it only selects your first subscription here, so if I do this, you will see that I'm not as lucky as we thought I was. I have had a number of 33 alerts over the last couple of days. I can click on them. I get the details of the rule that has fired, the severity, the current status, so an alert can automatically close if the condition is no longer met, which is really handy. And I can also add a state myself, which is acknowledged or resolved. And as you can see, I'm a lazy pain. Another thing I can do from this view is manage all my alert rules. So I get a list of all the alert rules I have defined. There's the annoying bug again. I get a list of all the alert rules I have defined, and I can get a list of all the action groups I have defined. So this is how I set up my instrumentation, monitoring, dashboards, alerts, the whole shebang for the applications already in Azure. Now you might be interested in how to do this for my own code. We only have 7 minutes left, which is plenty of time. What you need to do is first of all create a location where your metrics and your logs are going to land. This is called Application Insights. So what you can do is you can navigate to Application Insights in the menu on the right, create a new workspace, and this is where you can land your metrics and logging. The one thing you have to pick up from here is what is called an instrumentation key, which you can find on the top left. Is there anybody with a photographic memory? I know you're lying, doesn't matter, I delete this night. Now this key I am going to use for my own code to emit metrics and logging. So let's see how I do about metrics. One of the things I am doing is I am installing the package Microsoft.azure.applicationinsights, something like that, which is a NuGet package. This is the SDK I referred to earlier. And in that package there's a class called telemetry client. I'm going to hook that up for my dependency injection. Not really that difficult, it has a parameterless construction. I just don't want to new up anything on my code because I don't like the word new. Now this gets injected in my code, I get an instance, and now I want to emit a metric. What I do, pick a metric by name, don't hardcode your strings, really, don't. I pick the name of one or more dimensions that I want to record, and then I track the value, which is 1 in this case, and the dimension is add alias. Ta-da! This is all that you need to do, and now you can create those great fancy graphs and alerts and everything else from your own custom metrics as well. Logging, unfortunately the same boring story. I can inject the iLogger interface that is part of ASP.NET Core and just write lines to it. And what I'm doing here is I'm not using string interpolation. So this is not an error. What I'm using here is called structured logging, which means that I'm not only just recording a string, but I'm recording a string and a property bag of key value pairs. And the key value pair here will be alias to the serialized request. And we will take a quick look at how I do dependency injection for the logger interface later on. But what is important to know is that the application insights implementation will only look for the instrumentation key in your app settings, and the rest will all work out of the box. And then you can create graphs. The one thing that I don't like about application insights is that it always runs in the cloud. Especially if you want to do some local debugging, you're going to emit stuff to the cloud that's probably going to mix with that of other developers, unless you have your private application insight workspace, which probably a lot of you don't have. But there's another big disadvantage, and that is that it takes roughly 5 minutes for application insight to ingest data it gets. And that's a really long feedback loop if you want to debug something locally. So what I'm doing, I am not hooking up application insights directly to my iLogger interface. What I'm doing here is in my section that configures my logging, is checking my runtime configuration for a property called useSec, which is another. Let me go back one step. Sorry, I'm hooking up nlog, which is an in-memory logging system, to the iLogger interface, which is something like Serilog, and I think Serilog is winning, so I'm old-fashioned. And what nlog allows me to do is register just more than one target for the log stream, and I can also define filters. So in nlog, I am differentiating between audit logging and tracing. And tracing I'm just storing on the local file system that I can fetch later on whenever there's an issue I want to troubleshoot. Or you can emit it as well to an HTTPS point if you want to pay for that. And what I do with the rest is I'm going to divert it to application insights if I'm running in the cloud. And if I am running locally, I'm going to route it to sec, which is just another data ingestion and visualization engine, with the added advantage that it works instantaneously and it is free for developers on your local machine. And to give you a simple look at how easy that is, this is what I do to hook up nlog. It's basically registering an implementation for the logger and the nlogger interface. Above that you see two rules to route logs, and above that I'm going to add another target, which is my logging target, and I new that up as either an application insights target or a sec target. Now for sec it means really basic functionality, but that my logs just keep streaming in here and that I can search through them. I don't know, to do which is good enough for me when working locally. But in the cloud, everything gets streamed to application insights. So if I go there, open up the correct workspace, and I go to a magic thing called search, I can see all my logs of the last 24 hours. This is a continuously running demo, and you see it has generated a little over 2 million lines of code. Now you want to see how fast I can search through that. There goes the demo effect. Normally it's instantaneously. So searching your logs in Application Insight is really, really fast. And from here you get all the things that you would expect from a logging platform. When I open up one, I get all the related log entries. I can go to the things that happened before and after. I can go to similar things in other requests and all the things that you would expect here. One more thing that I want to show, because my 7 minutes are up, is that instead of search, I can go to metrics. And here now I just not have just one metrics namespace, but I also have one which is called Azure Application Insights, which falls under the header of custom. And when I open that up, this is where I will see the metrics that I'm generating for my own application. And from there on, it works just the same as the things that come from the stack down below. So this is how easy it is to work in Azure with monitoring and logging tools. And for me, there is no excuse to not use them. Now to wrap that up, 2 more things, because just one is boring. The first one is, I have this demo running for a couple of weeks now. It is a demo that resets itself every 4 hours. It has metrics it emits, it has logs it emits, and all the things. And you can all download it from GitHub and play with it as well. The second thing is, like I said, dashboards, but also alerts and alert groups. They are all just resources in Azure. And resources in Azure means that they are governed by the Azure Resource Manager, which means that you can get JSON templates for them and that you can roll them out as part of your complete infrastructure for your application. So you can create JSON files that describe what your dashboards and your alert rules and your action groups should look like. And you can roll them out to acceptance and then production, and it works like a charm. Now I'm not going to show that to you because a simple dashboard contains 2,500 lines of JSON. I will show you how you can export it, because I tried writing it once and it's a bit of a pain. You cannot get it through the normal way you would generate an ARM template, which is going to the resource group and then to automation. But what you can do is you can go to what is called the Resource Explorer and then find the location where the dashboard is, which is URL shortener, and then under resources, here you can find the dashboard JSON. Like I promised, 700 lines, fantastic JSON. So I would highly recommend you take this approach to your monitoring and logging infrastructure if possible, and have them effected automatically out of source control. Now that's all I wanted to share with you, except for one thing. Pat triggered me at the start of this talk that there is one thing that I didn't talk about in my talk, because this is like the 3rd time I give this talk, and that's alert fatigue. And alert fatigue is the thing that can get nuclear plants thrown down the drain. Alert fatigue is a thing when you define so many alerts that go off so often that people start ignoring them. And that's as easy as it is now to generate an alert rule. Please mind that they only fire whenever there is something that needs your attention right now, and that right now attention is not something that occurs too frequently. Because if it does, people will either quit their job, get sick, or your nuclear plant will melt down. Any questions? There you go.
Do you even need the log analytics anymore?
What I showed you in Application Insights for your own logs, you can also do for logs from the platform, and then it's called log analytics. So that's where the same thing with metrics, you have 2 stacks, you also have that for logs. Anyone else? In that case, oh, there you go.
So these events and application insights are sampled, right? So how do you aggregate everything and not just sample it?
You can sample it. You don't have to.
Is it not the case that the platform already samples all your events for you?
If you get really high traffic, it will start sampling automatically, yes. But it also, I think the information you have is what it used to be. Nowadays you can specify how much you want to pay. And if you want to pay for ingesting all the data, as far as I know, the platform will happily do it. So the question I normally get here, especially from open source developers, what was it cost? And that is the reason you probably want to use sampling, because you're going to pay roughly €2.50 per gigabyte ingested. And gigabytes can stack up quickly if you're recording a lot of metrics and emitting a lot of logs, especially when you add a lot of structured logging. But you're also going to pay €2.50 roughly for every gigabyte retained for a month. So if you're going to retain a lot of data, that's going to cost you as well. So that's probably a reason you want to use sampling. If you are using sampling, the platform in the client will try to sample mostly errors and failures and everything of the request that caused the error. So you will hopefully get the most interesting things, the longest dependency calls. So that's about sampling. Any other questions?
Not really a question, but a suggestion maybe. Not everybody might be using Azure.
Hmm.
There are a lot of open source or other alternatives to using application insight and metrics. For example, the stuff from influx data. They have a whole stack with the same kind of visualization and time series database, etc., which is open source.
So the thing that I always do wrong is only after the third question or remark I start repeating them. But the remark is there's a lot of alternatives to Azure. There are a lot of free open source things that you then have to run on VMs that you have to pay for, or on real machines. There are a lot of alternatives as well. There is, I don't know, Datadog. AWS has a thing that does the same. Google is well known for storing lots and lots of data and making it searchable. There are a lot of alternatives available. You're completely right. But I use Azure, and that's why I do my demos there. Can I just continue taking questions?
Yeah, one more. I think after this presentation we go to a drink in the bar, and if you have any questions.
How about when the first person starts walking out, then I wrap up.
Oh, that's a deal.
There you go.
Short one. Is it also available for Linux virtual machines in Azure, or does it only work on the Windows platform?
All the stack things that are available for everything. There are metrics available for virtual machine, you know, CPU usage, the storage account that hosts the disks. You can get the transactions for and the storage size and all the things. I do know, I think that the latest version of the Application Insights SDK is based on .NET Standard, which will probably mean that you can run it on Linux. But don't pin me on that one. And if it's not, you can hold your breath, probably till it is. You're welcome. Anyone else? Okay, now before people start walking out, we're done.
Okay, Henry,
thank you.
Thank you very much. Henry, with also a little surprise from a format for you.
Thank you. That's why I keep
Normally
returning.
From lemonade, but in this case it's from beer.
What gave it away?
Okay.
Thank you.
Big applause again for Henry.
Dank u wel.